Okay, hello. Hello guys. Hello Mr. Eric, Mr. Ryan.
Hello.
Hello.
Today we talk about power
Up. Power up.
of 3.
Oh, the power of 3.
Okay, so what does it mean? It means that
Like,
we're given a number like 27. You need to return 2.
9. I did because it is in the 3 times tables.
Because it's not exactly in the 3 times table. It's in 3 to the power of 3. So it's basically 3 to the power of x equals n. If I give you n, so it's basically 3 times 1, 3, 3 to the power of 2, 9,
And
3
if
to the
it's
power of 3.
8.
No, look, 27. And what's next? 3 to the power of 4, 81, right? So basically, if it's 3, 9, 27, 81, and then you need to tell me it's true, otherwise it's false. Any ideas? Any ideas? Any thoughts?
All we need to do is try 3 to the power of, then go like 1, 3 to the power 2, 3 to the power 3.
And
If
then-
it's bigger,
Then
then it's false.
it's 4. Yeah. And then if it's equal, then what?
It 2
Okay, so look,
little.
it's 0. 3 power. If the input is 0, what will happen? It's 0.
We can't find it.
So it's false, yeah?
Yeah.
And if it's minus anything, it'll be false.
Yeah.
Right? Because minus negative numbers can't be power of 3, right?
Yeah.
Okay, so 1. How about 1?
Power of 1.
3 power of 0. This is special, so 1 is okay. So look at your algorithm is quite good, okay? Define power of 3, okay? N, right? Yes? So look, if n is smaller or equal to 0, we return what?
With false.
False. Okay, then if n is 1, return 2, right? Yeah? Am I right?
Yeah.
Okay, so now we start from start from 1, okay? Yes? You tell me what to write. While x what? What did you say before? If it's smaller, if it's bigger, if it's smaller than n, right?
Yeah.
X what? Times 3. How do I write it?
To the power 3.
X time multiply equal 3, right?
Mhm.
And then what should I write here? Return what?
Return false.
Return, we need to check if x is bigger than n or equal n, right?
Return n.
So what should I put here?
Return n.
No, return true. Look, x smaller than
Return
n.
n.
No.
Equals 1.
No, look, you just say multiply 3 until it's equal or bigger,
Yeah.
right? So and here there are 2 situations. One is smaller, one is bigger, one is equal. So one is equal is true, one is bigger is false, right?
Mm.
So what should I write here?
Return true or false.
No, return x equal n, right? If it's n, then it's true, right?
Yeah.
Yeah, am I right? Does it make sense for you?
Yeah.
Yes. What's the complexity?
I log n.
Yeah.
I log n to the power 3.
Yeah, log 3n. Okay.
Log
Thanks.
base 3
Okay. So okay. So this way,
What's the
look.
space complexity?
space complexity.
I won.
Yes. Well done. Okay. So look.
I said that first.
Okay. Look. This is going up. How about we going down? From start from n, we divide by 3.
What?
Yeah. And until it's 1, right?
Yeah.
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 For example, 27.
Yeah.
Yeah, it's multiplied by 3, and I can divide it by 3, that's 9. It's multiplied by 3, I divide it by 3, 3. 3 by 3, 1. So if it's 1, it's,
How do you turn this off?
it's power of 3,
Turn
right?
this off.
No, you don't need to. Yeah, am I right? Yeah, okay, so this is the same, yeah? Look, we can do this. Why? Anyway,
While
n can be divided by 3. Look, right, Eric. Why n can be divided by 3? Eric.
Yeah.
0. 1 n can divide by 3. Then what should I do with that? Sorry?
There's 2 daddies. Now there one.
No, that's okay. I mean,
2
Eric.
daddies.
Eric, why n can be divided by 3? What should I do? Can you?
Divided by 3.
So how do I write it? N
And divided
divided by 3, divided by equal 3, right? Then return what?
Return 2.
No, like before, return what's the
Return
return?
n equals 3. False!
N equals what? N equals what?
X.
N equals what?
3.
No.
3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
N equals what? You divide it by 3 until you get what?
1!
Yes, well done. If it's actually you can divide it
I
by 3.
should get that.
Yeah, that's okay. This is the same.
Because
What's the time complexity?
log to n to the power 3.
Yeah, and what's the space complexity?
1.
Oh, 1. Okay, so look, this can be written in recursion. Yeah, how do we write it? Look,
That's a curve.
with recursion. Look,
Ha.
no, can you be good boy?
Ha.
Anyway, look, we can do it in recursion. Look, return n divided by 3 can be divided by 3, yeah?
Equal.
And
So,
you don't need the right power 3 and what?
power 3.
What should I put here?
And divide by 3.
Yes, recursively. Yeah? You
You
get it?
need to divide by 3.
Yeah, okay. Good job. This is one way of doing it. How about look. Eric, look. 3 to the power of x equals n, right? So how can we write it? We can write it x equals what? Log 3n, right? Yes? Yes? 3 to the power of x equals n, and x is log 3n, right? Yes?
Yeah.
Okay, so if we calculate this function, because we don't have log 3, but we have log 2, and we have a log 10, okay? These two functions are available. And then let's say,
Why?
because in mathematics, in computer knows these two functions. And possibly, then you can convert this to this, but it's a bit tricky, okay? It's a bit tricky. It's a bit tricky. How do we compute that? The log AB, right, equals log 2, you can choose any base, yeah? Base C, B divided by log C, as long as it's the same base, okay? Okay, so this can be converted to log 2 n divided by log 2 3, okay? Yes? You just need to know, and if we calculate this number, and then it's a floating number, then if we can compute its integer part, yeah, integer part, and then let's say if x is integer, then we can just write return 3 times x equals n, return that thing, okay? You don't need to understand fully, but you just have to see that that's the one solution of using mathematics, okay? How about binary search?
No.
Remember we talked about binary search, yeah?
Mm.
Yeah? So look, define, you tell me, okay? Power of 3 n, right?
Column.
If
Column.
the same, if n smaller than 0, return what?
Return false.
If n is then look, then left. Let's just use L and right. L, right, right equals left will be 0, right will be n. Okay? Yeah? Two boundary. Okay? Y, wire. L smaller equals R. Why these two range is not meeting in the middle? Yeah? Mid equals what? We click left and right. What's the middle? What's the middle? That's 3, that's 4. What's the middle?
4.
Yeah, how do you
Yeah,
get a 4?
left and right divided by 2.
Yeah, L plus right divided by 2. Okay, that's middle. Yeah?
Yeah.
Okay, let's calculate this big n value. Yeah? N equals 3 times mid. What does it mean? Power 3 to the power of 3 to the power of mid. Yeah? This is the same thing as power. You can use this 3 power mid. It's the same thing, okay? You can write it as well. Right? Then I calculate this mid. Okay, now if n equals what? If n equals n, What should we
Be
return?
10 minutes.
If n equals n, what should we return?
If n bigger than n, make
No.
it false.
No, if n is n.
Oh, true.
Yeah, because we found a value, yeah? If n, if this value is bigger than n, what does it mean? Smaller n. No. Binary search, remember, we need to, look, this is L, this is R, and this is mid, yeah? If this is the bigger, please, if this is bigger than the value we want to find.
Is we now.
If this is the bigger than what we want to find,
You go down.
go down, yeah?
Yeah.
Is it go down? If this 3 to the power of mid, yeah, is actually bigger than the 3 to the power of x, right?
Yeah.
We want to find the x, yeah? So the value must be in here, right? Yeah?
Yeah.
So R equals what? R here. R equals what? We want to move here. R equals what?
Mid minus 1.
Yes. And then else, if it's smaller, then it should be in this range, yeah? So what should I do here?
Left equals mid at 1.
Where down? And then when it's
False.
when we can't find the value, return what?
False. I said it first.
Yeah.
Yeah, but I can only go first.
What's the time complexity?
Look.
What? Log what?
N.
Oh, log n? Yeah?
Yeah, to the power 3. No!
What's your answer?
Uh,
Binary search is log n.
2.
Log 2n, yeah?
Yeah.
However, look at this. This needs time, right?
Times 3.
3 to the power of mid.
Three to the power of mid.
Remember, we talked about how to calculate the power function using the binary search. Yeah? Remember, we talked about 2 to the power of 5 equals 2 to the power of 4 times 4, 2, right? 2 to the power of 4 equals 2 to the power of 2 times 2 to the power of 2, right? Remember, we talked about this previously, right?
Yeah.
So this needs the log n as well. Yeah? It does not come free. You just cannot calculate it in O1 constant time, right? The computer needs the O log n to find the power function, right?
Yeah.
So that will be O log n squared. Okay? This is a bit tricky, but binary search, right? Look, binary search, log n, right? Yeah? Every time I divide into half, right?
Square.
Yeah? Divide into half.
Boo!
Yes? And then this is binary search, okay? So
And
you want me to erase some bit of it and you fill a blank, or you want to erase everything and you write one of the approach I just talk about. Which one? Which one do you prefer? Which one who do you want to come first? You? You want to challenge? Yeah? Yes or no?
I want the two.
Okay, I erase one of it and then you tell me, okay?
Look,
Close your eyes.
line.
Yeah, one line. One by one, okay? Okay, turn around. Okay, I'm going to erase this. Okay? Can you tell me what should I put here? If n equals n, we find it, we should what?
Return true.
We're done, return true. We're done. Okay, you want to do the same exercise or you want to erase all of it and then
No, you can go out 1 line.
one done, okay? Interesting. Close eyes. Close eyes. Okay, write a new pick.
Only 1 line. To the easiest one.
Okay. Okay. Here.
What?
Yeah. So,
Left,
right
right equals 0.
Yeah, left boundary is 0, yes? Right? Comma. What's the right boundary? What's the right boundary?
N.
Yeah. Or a very big number is okay. As long as it's bigger than
Yes.
bigger than
Big brain.
bigger than As long as this number is bigger than 3 to the power of x. Yes? Yeah?
Yeah.
Okay. Well done, well done. Good job today. Very well done today.